Greetings and welcome to my channel. I'm Mr. D, and today we'll be discussing some important science terms and the scientific method. You may have seen and used many of these terms in your everyday life, but today we're looking at them with an eye towards how they are used in the sciences. The definitions we'll be going over are not hard and fast ones, in that different reference materials may define the terms differently, but in essence they'll be providing you with the same information. Let's say you get up in the morning and you pull back the curtains of your bedroom window and you see the sun is in the sky a short distance above the eastern horizon. This tells you that it's morning. How do you know? You know this because over the millennia, many people have observed the sun rising out of the east at the start of each day. What we have here is a fact, which is an observation that is accepted to be true. This brings us to our next term, observation. An observation is a recording of information about phenomena using your senses directly or with scientific instruments. So your observation here was recognizing that the sun is up and a little above the eastern horizon. You've recorded this information directly with your eyes. If you then look at a thermometer nailed to the window frame outside your window to see what the temperature is, you're making an observation indirectly using a scientific instrument, the thermometer. The first observation is a qualitative observation, one that describes phenomena or properties of an occurrence that does not rely on numbers. The second observation with the thermometer was a quantitative observation. It's one that consists of a number and a unit, 78 degrees for example. You get out of bed and you go to the closet and flip the switch to the closet light and nothing happens. You probably then ask yourself, why won't the light come on? In science, this question that you want to answer is known as your problem. A problem is a question you wish to answer. You have enough light coming from the bedroom to see what you need, so you get out your clothes for the day and dress. You trundle on down the stairs to the kitchen and find that your mother has been heating water for your breakfast of instant oatmeal. The burner is on low, so you know it's going to take forever for the water to boil. So you give it some thought, and you figure that if you put the burner on high, the water will boil sooner. You wanted to know what you could do to make the water boil sooner, and the answer to your question, your hypothesis, was that it would do so if you increase the amount of heat being transferred to the kettle. A hypothesis is a proposed answer to a question, or a tentative explanation for observations. It can be tested and refined, or replaced as needed. After eating your oatmeal, you're still hungry, so you grab an apple from the fruit bowl, and as you walk to the sink to wash it off, you drop it, which gets you thinking about gravity and how it works. This reminds you of Newton and his law regarding gravity. Scientific laws summarize many experimental observations and describe or predict some part of the natural world. These laws are explained by theories. These are well-tested set of explanations derived from a group of well-tested hypotheses. They explain why and how things happen. How do you test a hypothesis or theory? You do this through experimentation. An experiment is a procedure designed to test a theory or hypothesis by manipulating one or more variables that affects the outcome and observing the effects of the changes that are made. Suppose your father is setting up his vegetable garden, and in discussing the care and the needs of the plants, he wonders if the amount of light has any effect on the growth of the plants. After some back and forth between the two of you about this, it's decided that it does. The two of you decide to perform an experiment, or more specifically, a controlled experiment. In this experiment, you'll have several plants, all of them being treated the same way, with the exception that all plants but one will have one of the variables that can affect its growth withheld. The one plant that doesn't have anything different done to it is your control. The control is a thing or a group that contains every feature of the experimental group, but none of its variables are manipulated. So you decide that plant 1 will be your control, so it'll be planted in the middle of the yard in full sun as usual. Plant 2 is planted in full shade. Plant 3 is planted in such a way that it gets about 3 hours of sun. Plant 4 is planted so that it gets about 6 hours of sun. After everything is set up, you and your father state what you think the results of the experiment will be. This statement, based on a hypothesis about what you expect to happen, is called a prediction. Throughout this discussion of your day, we have seen that you have used different aspects of what we call the scientific method. This is a process involving experimentation and observation to solve problems and answer questions. Let's put all these pieces together into a scenario that you might have actually experienced in your day-to-day life And in doing so, we'll see that you actually have used all the steps of the scientific method intuitively, not even realizing that there's a name for the process that you've used. So let's say you sit down at your desk to study for an upcoming test, and you decide you don't have enough light to see what you're doing. So you reach over and you turn on the lamp, or at least you try to. Light didn't come on. So you might ask yourself, why didn't the light bulb light? There's your problem, the question you wish to answer. So you then answer your question, well, maybe the bulb was burnt out. There's your hypothesis, your tentative explanation. So the next step in the process, would be to see if a new bulb would work. There's your experiment. You're testing your hypothesis by changing out the bulb and replacing it with a new one. So let's do that. Still didn't come on. So you tested your hypothesis and turned out that your hypothesis was incorrect. Which happens. If every hypothesis was correct, we would know everything. We wouldn't have to test anything. We'd have all the information in the world that we need to know. So then, since your hypothesis turned out to be incorrect, you have to come up with a new one. Maybe the maybe the lamp wasn't plugged in properly. So you reach on down and test it and check it, see, give it a good shove and plug it in, see if maybe that's what the problem was. And lo and behold, that's what it was. The plug wasn't properly plugged in, so that's why your light didn't come on. So you came up with a second hypothesis, came up with another experiment to test it, and this time your experiment proved that your hypothesis was correct. Let's look at another example, and this time we'll include a controlled experiment. Let's say I have a pet rat, and I'm tired of spending so much money on the special food for him. I'm wondering if what I feed him has an effect on his health. There's my problem, the question I wish to answer. Does the quality of the food affect his health? I think that it does. There's my hypothesis, the answer to my question. I decided to set up a controlled experiment to see if this is the case. Since this is a controlled experiment, I will need to identify the different variables that could affect a rat's health and make sure that all of these are the same for every rat except for what I'm feeding each of the rats. Recall that my control will have none of its variables manipulated. It will be getting the same food that I always fed my rat. I think the better the food is, the healthier the rat will be. There's my prediction. The variable I'm manipulating, the food, is my independent variable. The health of the rats depends on what I do when I manipulate this variable, so it is the dependent variable. Variables I will want to keep the same for all the rats will be the sex of the rats, the age of the rats, the amount of exercise they get, their access to water, the size of their cages, and the amount of time they get to socialize. I'll set up the experiment with 5 rats, with one being the control, and then 4 diets that are different from what I normally feed my rat. My rat gets science diet, so that's what the control will get. The other rats each will get one of the following: PetSmart Premium Pro Rat Food, Purina Pro Rodent Diet, a generic store brand of pet rodent food, and a standard teenager's diet of soda, candy, chips, and other snack foods. So I let my experiment progress for several weeks and observe and record my observations over this period of time. After a few weeks have passed, I take a look at my rats and I find the following information, make the following observations. My control rat has the same health that my pet rat has. My PetSmart Premium Pro Rat Diet has actually produced a rat that's even healthier and a little bit larger. The Purina Pro Rodent Diet has produced even healthier and even larger rat than the previous 2. The generic store brand of pet food has actually produced a smaller, less healthier rat. And not surprisingly, the standard teenager's diet produced a rat that is not nearly as healthy as one would hope their rat to be. So my conclusion is the quality of a rat's diet will affect its health. Today's episode is brought to you by the element helium. Helium was first detected as an unknown element while observing the sun during the solar eclipse in 1868 by several people, including French astronomer Jules Janssen and Norman Lockyer of Britain. Lockyer named the element after the sun based on the Greek name Helios. Briton chemist Sir William Ramsay discovered the existence of helium on Earth in 1895. Helium is a monatomic element. It's a gaseous element with the colorless, odorless, non-toxic, and inert properties. It is the second most abundant element in the universe, making up 24% of its composition, and it's the second least dense element. Most of the new helium in the universe is created by nuclear fusion in stars, such as our Sun. Most helium present on Earth today is created by the natural radioactive decay of heavy radioactive elements such as thorium and uranium. While balloons are perhaps the best known use of helium, they are a minor part of helium's use. Helium is used for many purposes that require some of its unique properties. Helium is used as an inert gas atmosphere for welding materials, such as aluminum, in rocket propulsion to pressurize fuel tanks, in meteorology as a lifting gas for instrument-carrying balloons, in cryogenics as a coolant because liquid helium is the coldest substance, and in high-pressure breathing operations where it's mixed with oxygen, as in scuba diving. Thank you for watching my video. Hope you found it both informative and interesting. If you did, please smash that like button below and consider subscribing and hitting the notification bell so that you know when my next video comes out. When it does, please join me again. Until then, be good, be careful, and don't trust atoms. They make things up.